Live. There we go. We're live. Okay. So, topic. We're talking about when a function is increasing or decreasing. And it is 9:4:19. Okay. So on my little side here, we're talking about x values. I'm going to circle that. I'm going to highlight it. Whatever you want to do, it's just like muy importante, okay? We're not talking about the y values. We're talking about the x values, okay? So from the function below, find the function. T of 1. Now, T of 1, think about this. T of 1, that 1 is an x value, isn't it? It is an x value. So if I go to 1, what's the temperature? About 25. Let me show that again. So it's easy. T of 1, that's 1, 2, 3. So I go to 1, T of 1, and the temperature is 25. So the question is, what's the temperature after 1 hour? Okay. So the answer is the height, but it's from the x value. Got it? So T of 3. What's T of 3? Well, we go to 3, and it looks like it's about 30. Okay? About 30? Okay. T of 0, 15. Okay. Now, yeah, you know when I did the circle around it? Zoe had got the 1, didn't it? Yeah. So now think about this. For which values is increasing, okay? So think about this. We're talking about what hours. This is why it's the x values, okay? From what time to what time is it getting warmer? That's the x values. Does that make sense? So it's getting warmer from 0 to 2. I didn't say it went from 15 to 35. I'm saying it got warmer from 0 to 2, okay? We just use for right now from 0 to 2 hours, okay? Now, I like interval notation. Think about this, okay? Now, here's a very important question. Right at 2, is it getting warmer, colder, or is it at the top, right? So it's no longer increasing right at 2. Do you agree with that? Here it seems as if it's going up. You guys agree with that? So think about slope. What's the slope right here? 0. That makes sense? So it's not doing anything at the top. So in interval notation, I'm going to say this. Bracket 0, comma 2, parentheses. Okay, interval notation. We talked about this yesterday. Okay, at 0 hours, it is increasing, right? Right at 2, it's at its highest, okay? 1.99, it's getting warmer. 1.999, it's getting warmer. 1.99999, it's getting warmer. But right at 2, it's at the top. Got it? So at 2, it's not getting warmer or colder. It pauses. Okay, now, for which values is it decreasing? Well, it's decreasing from 2 to about 7, right? But do we know what's going to happen beyond here? What if I put an arrow here, okay? We don't know, right? So let's just say at 7 we'll stop. So we would say it's going and decreasing from 2 to 7. Now, here's a question for you. I don't think there's a wrong answer, but right at 7, does it look like it's still cooling down?
No.
Do you think it's level? So let's use a parentheses, because at 7, it's leveled off. Okay, good. Okay. Where's the local max? Right there, right at 2 and 35. So local max is at 2, 35. Now, here's a great example of these two are totally different answers, aren't they? This is an interval, but you can see from the question it's got to be an interval. And this is a point, right? So don't get confused. This is saying it's decreasing from 2 hours to 7 hours. And this is like, when is it? Well, it's at a point 2 through 5. So I'm going to write that down. This is a point, okay? Just so I don't mess myself up, okay? Okay. Now, what is the net change? Now, the net change is the y values. The net change is the y values. So the y values then, from 1 to 3 p.m., it's going to go from a height or a temperature of, looks like 25 degrees, and it goes to, at 3 o'clock, a height of 30 degrees. So it's easy. What's the net change? 5 degrees. But we're going to say -5 because it gives us more information. Does that make sense? So that change is -5 degrees. And I think the negative is important because when you get to physics, and if you ever take physics, the positive negative is important. In velocity, if it's a negative, it means you're going backwards. Okay? Okay, example 2 we're not going to do. You can scribble that off, okay? All right, now, flip the page. And is Desmos loaded up?
Yeah.
Good. So I'm going to stop recording here. And we're going to go to Desmos, okay?